So hi guys, good evening. So we'll be continuing with the physics session. Good evening, right? So today we'll be doing mechanical properties of solids, liquids, and if possible thermal properties of matter. That is today's topic. So we'll be doing 3 topics. Let me see. So let me share the screen, guys. Right, I hope you guys can see this. So yesterday we were doing till gravitation, collision, center of mass, gravitation. Today we'll be doing this properties of matter, which is combination of fluids and this one and this. Then we have thermal properties. We'll try that. Okay. Just a second. Yeah. A cylinder of height 20 meters is completely filled with water. So there is a cylinder whose height is 20 meters. So there's a cylinder whose height is how much? 20 meters. Is filled with water. The velocity of efflux of water in meter per second through a small hole on side wall of the cylinder near its bottom is. So there is a hole here. So there is a water in this. What is the velocity of efflux? That means when you make a hole, a velocity, the water will come out, right? This is called with some velocity. This velocity is called velocity of efflux. This V is equal to root 2gh. And here area of this is small a, area of this is capital A. When A is much greater than small a, that is area of the hole is much smaller than the area of the tank. In that case, V is root 2gh. So root 2 into G is 10 into height is 20. 20 meter per second is equation, right? So velocity of efflux. So see the units, 20 meter per second. Next one, this is fluids. The next one is materials. A wire suspended vertically from one of its end is stretched by attaching a weight of 200 Newton to the lower end. The weight stretches the wire by 1 mm. So the given data is force is 200 Newton, the stretch is 1 mm, and the elastic energy stored in the wire. So he's asking the elastic energy stored in the wire. So if you remember, elastic energy density, that is energy per unit volume. Energy per unit volume is half stress into strain, right? Now total energy stored is half stress into strain into volume. So what is stress? Force by area. Strain is elongation by total length into volume, area into length. Volume is area into length. A and LL gets cancelled. It is half of force into delta L. What is the force, guys? 200 into delta L. The 200 is a SI unit, 1 mm. That is 1 into 10 power minus 3. Right? This one is 0.1 joule. 0.1 joule. So again, I'm repeating energy per unit volume in a stretched string. Stretched string. Similarly, spring. If you take a spring, what is the energy stored, guys? Half k x square. Half into k into x into x. X square I can write x into x. What is kx? Force. So half force into x. Same thing we got here. Half force into delta L. So you can relate the string as spring. So their force constant k, right? K into x is the force here. Hope you understood. A wire fixed at the upper end stretched by length L by applying a force F. The work done in stretching. So wire at a fixed a wire is fixed at the upper end. Now you are applying a force F and stretching it by a length L. So the elongation is nothing but length small l. So in that case, what is the work done? So work done, small work done, if you are moving it by dy in y direction, no dy. dw, small work done is fdy, right? Small work done is f dy. Integrate this. So imagine already you have pulled it till y, and from there you are elongating it by dy. So it is like string. This is the actual length L naught. You have already pulled it by L y, and from there you are pulling it by dy. I hope you understood this. So after stretching y, you are pulling dy. So integral f dy. So how to get force F now? So force is ya L by capital L. L capital is the length, and L is y here. That small length elongation is nothing but y. This is the formula we get from elongation. I'll just try to go to the notepad and try to solve it. Is it? So again, I'm repeating so that you won't ask the question again. So we have a string, guys, of length L naught. You are trying to apply force F, because of which it is getting elongated. So L naught has become, it has came till here, which is extra y. So L naught got extended to y, and from there you are extending it to dy. So in this small juncture from y to y plus dy, the work done by force dw is f dy. Total work done is integral. So how do you get force? Y is equal to f by a by delta L by L, right? So y is equal to ya delta L by L. In this case, ya delta L is dy. Delta L change in length is how much? Dy, and length of this is L naught, right? Length of this is L naught. Sorry, this is y. Delta L is nothing but y, not dy. Delta L is y. So substitute this here. Integral ya. This is Young's modulus into area into small y into dy by L naught. Young's modulus a by L naught comes out. Integral y dy is y square by 2, 0 to L. The limits, the wire got stretched from 0 to L. So finally is asking, when the string gets elongated to L naught and L, what is the work done or energy stored? Ya by L naught into L square by 2. I hope you understood this. Ya L square by 2L naught or 2L. Take the screenshot of this, guys. Question number 3. We have that option. So Ya by L is F. Ya by L is F. So FL by 2. Sorry. Work done, no? FL by 2. Right. Fourth one. Spherical balls of radius r are falling in a viscous fluid of viscosity eta with a velocity v. The retarding viscous force acting on the spherical ball is, right? There is a spherical ball of radius r in a viscous fluid of viscosity eta. There is a liquid everywhere. It's like you are dropping a steel ball in oil or some gum, right? It is viscous fluid and it is going with velocity v. The retarding force is asking proportionality. So viscous drag, that F viscous is 6 pi eta RV. If you remember, this 6 pi eta RV. Directly proportional to R, but inversely wrong. Directly proportional to both R and velocity, right? Inversely proportional to both, wrong. Inversely proportional to, wrong. So it is directly proportional to eta, R and V. If viscosity is more, viscous drag will be more. If radius of the ball is big, like if you are dropping a small ball and another heavy ball of radius, larger radius, again viscous drag will be more. The ball is moving faster, viscous drag will be more. Fifth one, if two soap bubbles of different radii are connected by a tube. So this experiment I used to do, guys, in a class. So I used to take a, this one tap, and both sides I used to keep two balloons. You can give a try here at home. Two soap bubbles of different radii are connected by a tube. Air flows from bigger bubble to smaller bubble till the size becomes equal. Air flows from bigger bubble to smaller bubble till the sizes are interchanged. Air flows from the smaller bubble to the bigger. There is no air flow of, there is no flow of air. So I would expect answer from you guys. Easy conceptual question. Let me see how many of you have done it. So after the session, I'll post it, okay? Or I'll ask someone to post it. Clear? Just for now, try to solve the question as it is being asked, right? So it is Raghav till equal, okay? C, what is C, guys? What is the option C? I don't know. Let me see. Air flows from smaller bubble to the bigger bubble, okay? Right? So what is exactly happening? I'm taking the chance of this question and trying to explain you the other questions, like on the kind of similar concept. So whatever other questions they're asking, I'm trying to solve. So we have two types of things. One is air bubble in water and soap bubble in air. This air bubble in water or water drop. Both will get the same. So how? See this. If there's a water drop, if outside pressure is P, there's a single layer. So inside pressure is P naught plus 2T by R. T is the surface tension, R is the radius. This is water drop. And air bubble, if you take a container, there is water in it and there is an air bubble. Container, there is water in it, there is a air bubble. So even in this, the pressure is P naught plus 2T by R in both these cases. If there is a soap bubble, that is outside is air, inside is also air. So we will have two surfaces, one inside surface, other outside. So pressure will be P naught plus 2T by R. If we have a sphere, some arbitrary shape, okay, where we have two radii, this is R1, this is R2, these are two perpendicular, or Rx and Ry. Rx is the radius along x direction, Ry is the radius along y direction. In that case, it is, sorry, this is 40, 40 guys. So here it is, if it is soap bubble, P naught plus 2T by Rx plus 2T by Ry. Remember this, where Rx and Ry are the perpendicular radii. So in this question, so we have two soap bubbles. One is small, the other one is big. This is R1, this is R2. So pressure here, P naught plus 4T by R1. Here pressure is P naught plus 4T by R2. We have R2 greater than R1. This is bigger one, right? That means P2 is less than P1 because it is in the denominator. This is smaller than this. So pressure in 2 is less than pressure in 1. So when you unlock this, the air from here goes into this. So bigger one becomes still bigger and smaller becomes still smaller. This you might have tried when you try to blow air in a balloon. First it is difficult. At the start, you feel more pressure while blowing air into the balloon. And as the size of the balloon increases, it becomes easy for you to blow it. And finally, boom, right? So you have to stop it somewhere or else it will break. I hope this is clear, guys. Even remember this. Screenshot will help you. Take screenshot. Clear. Thanks for that. And I'll be very happy if you just shoot me up with questions, doubts, right? Even generic ones. Guys, when did this go to mute? Were you able to hear till now? From sixth question onwards, not audible. Oh, I'm so sorry, man. Okay. From sixth, we'll just go back. Okay, okay. This is only sixth one, no? Right, right. So I'll just revise whatever I did. That was by mistake, I guess. So again, this is the question. What happened in this question? I'll repeat, guys. There is a container. There is water in this. You have put a capillary tube. So the height of the capillary tube outside is 20 centimeters. Then what they observed, the water height is 8 centimeters. Is it clear now? Right. So 8 centimeters. So why we got this? The glass is pulling the water up. So what is the force with which it is pulling? If the radius of the capillary is r, the force, the water contact is 2 pi r, right? So 2 pi r into t is equal to weight. Weight is pi r square into height into g. So pi r gets cancelled. The height h is 2t by rg, the height of water. So which he gave is 8 centimeters. So h naught, initial height is how much? 8 centimeters. Now, if this is going up with an acceleration, the height becomes 2t by r into g plus a. If acceleration is upwards, because pseudo force will be downwards. So we get g plus a. If the same lift goes down with acceleration a, we get h dash is equal to 2t by r into g minus a. Is that if it is at rest, a becomes 0, 2t by rg, which is h naught. So he gave when a is equal to g, h dash is equal to infinity. But we don't have infinity here, we have only 20 centimeters. That means h dash is 20 centimeters. It cannot go till infinity. The maximum what it can pull, the length of that condition, the length of the pipe available is 20 centimeters. If we have infinity, it will go till infinity, but we don't have till infinity. And other cases I gave is when it is going up and a is equal to g by 2. H dash is equal to 2t by r into g plus g by 2 is 3g by 2. So it is 2/3 of 2t by rg, which is h naught. In this case, 2/3 h naught. And here, if it is a is equal to, if a is equal to g by 2, h dash is equal to 2t by r into g by 2 or 2 h naught. Right? So 2 into 8, which is 16 centimeters, and 2 into 8 by 3, 16 by 3 centimeters. So these are the different case scenarios I gave. I gave 3 different case scenarios. And height as r of the, if r increases, that is capillary size increases, the pipe size increases, h decreases. R increases H. So as you increase the size of the capillary tube, H will decrease. So xylem phloem you might have heard in plants, right? They're very thin tubes. So using the surface tension, they take up water from the roots to the leaves in a tree or plant. So they use surface tension concept. Chromatography, capillary action, if you keep a tissue paper inside water, you see the same. Good. I'm happy you people understood. Thanks for that. Right. Now it is clear. So it is 20 cent. I'm not just doing this particular question. I'm trying to touch or revise the areas around it. So it will be of good help to you. Seventh one, if S is the stress and Y is the Young's modulus of material of a wire, the energy stored in the wire. S is the stress. So S is equal to force by area. Y is the Young's modulus. The energy stored in the wire per unit volume. He's asking per unit volume. So we already discussed. This one is 7. So stress is equal to force by area and Y he gave. So Y is equal to F by A by delta L by L. Right? This is what I know. Now, energy per unit volume is equal to half stress into strain. So Y is equal to stress by strain. No, stress by strain. So strain is equal to half into stress into strain is equal to stress by y. So half s square by y. Half s square by y. If they give you strain, you do similarly the same way. You get another answer, half stress by strain. Half s square by y. Seventh one. Eighth one is the terminal speed of a sphere of gold density 19.5 is 0.2 in a viscous liquid density 1.5 kg per meter cube. Find the terminal speed of sphere of silver density 10.5 of the same size in the same liquid. So he's saying radii are same. So R is same. Density 19.5. So he gave three different densities. Gold is 0.2. Okay, if the terminal velocity of gold is 0.2, what is the terminal velocity of silver? So I'll try to write the data here, whatever is given first, right? Eighth question. He gave gold and he gave silver, he gave liquid. So radius is equal to R, right? Density of gold he gave 19.5, right? Kg per meter cube. Density of silver is 10.5, I guess, is kg per meter cube. And liquid, just let me check liquid. Liquid is 1.5 and that is 0.2. So density of liquid is 1.5 kg per meter cube. And he gave terminal velocity of gold is 0.2 meter per second. Is asking terminal velocity of silver. This is how we should write. Whatever is given, this is what we have to write. Now, what is the equation related to this? What is the equation related to this? Right? Is it somebody written this or I have written this? So someone is accessing my screen now. Okay, so now the formula for viscous drag. So I'm just drawing the free body diagram. We have weight. Weight is how much? Mg. We have force of buoyancy. And if it is going down with terminal velocity, it has a viscous force, F viscous. When it is going at terminal velocity, that is acceleration is zero. That means weight mg is equal to force of buoyancy plus viscous drag, right? So what is the weight? Volume into mass. What is the mass? Volume into density of the body into, this is the mass, into g, v rho g. Force of buoyancy, volume into density of liquid into g, plus viscous drag is 6 pi eta r. From this, we can calculate the terminal velocity. This is terminal velocity, guys. So terminal velocity, this is volume, is equal to Vg, volume into g into density of body minus density of liquid. This goes to the left side, it becomes minus by 6 pi eta r. 6 pi eta. That is the general equation. Please do remember. So volume is how much? 4 by 3 pi r cube into g, Vb minus, sorry, density of body minus density of liquid by 6 pi eta r. Now, for both the bodies, radius is same, g is same, 4 by 3 pi, 6 pi are constant, r is same, eta, same liquid is same. So if I take the ratio, terminal velocity of gold by terminal velocity of silver, rest all they gets cancelled. Density of gold minus density of liquid by density of silver minus density of liquid. Am I right? Any questions in this? So we are recapping the formula. I'm giving you the derivation of how we got this formula. Then I'm taking the ratio and solving it. I hope you understood this so far. Now if I substitute terminal velocity of gold, he gave 0.2 by terminal velocity of silver is equal to density of gold 19.5 minus 1.5 by 10.5 minus 1.5. How much is it? 18 and this is 9. Who's that? So terminal velocity of silver is 0.1, 0.2 by 2, which is 0.1 meter per second. Screenshot for 8th question. is the solution. How to solve it? How come when I'm taking this, it's getting wrong? Who is that? Who is doing that underline one? This is density of silver. This is density of liquid. 10.5 and 1.5. Okay, 10.5 and 1.5. Any questions in this eighth question? Rishwana asked me at the start, I was telling I have to share the same with them and they will share this with you. Okay. So for now, take the screenshot. For now, take the screenshot of whatever question. See, it's just one screenshot, man. You'll get all these 9 questions in it. You can still take it. Okay. So this is done. We got point 1. Ninth question. A wire elongates by L-mm when a load W is hanged from it. The wire goes over a pulley and 2 weights W each are hung at 2 ends. The elongation of the wire. Give it a try. Good. Do it. Ninth question. There is a wire. It elongates by L-mm when a load weight is hanged from it. So you tie it to the ceiling. There's like, suppose there is one friend of ours who is 50 kg is hanging. The elongation is L-mm. Now what we are doing? We are taking the same rope, keeping it on a pulley, and 2 friends weighing the same 50 kg are hanging on it. Right? Now, what is the elongation? Is it going to be still L or decrease L by 2 or 2L or no elongation? Let me see how you just give a try. There's no need to mark here. Okay, so L by 2. L sir. Okay, Karthik L. Ramnathan. Ramnathan. Yeah, L by 2. Okay. Others, speak out. This is the time for you. No negative marking. No time constraint. Chemistry, Rajesh sir will be teaching. So according to schedule, it will happen. Oh, L by 2. Yeah. So most of you, L by 2. Okay. So how do we decide the elongation? Based on what? So we decide elongation based on the tension in the string or not. We decide the elongation based on the tension in the string, right? So what exactly is happening here in the first case? What's the question number? This one is 9. Right. So in the first case, there is a string, weight W. What is the tension? T is equal to W. Weight is nothing but mg. Okay. So he didn't say mass, he said weight W. So y is equal to F by A. F is how much? Mg by area of the string into delta L by L. So delta L is mgl by ay, or mg is equal to W, anything. Now when I take a pulley and hang 2 blocks of weight W, so will they move? No, equal weight, so they are balanced, right? They are equal weights, they are balanced, right? Now what is the tension T? Tension is still W. Here also W. Instead of hanging it here, we have another W to balance it. So tension is same. So delta L is again WL by AY only. So delta L remains same. It is L only, small L. So whoever got that L, they are right. For me, doing a mistake is not wrong. It is okay. Everyone does mistakes. There is no absolute. It's no one in this world who did everything right. So far, we don't know what is right. We are still discovering what is right. Things have been evolving. At this juncture, we have this exam, which is showing that whoever gets selected is right or smart enough. Maybe in future, things might change for us. Long time back, it was whoever got the physical strength. Now this mental strength. Maybe in future, it can be something else. So at this point, just give a try. Being wrong is fine, but not getting it corrected is the wrong aspect. That is what I feel. So get your doubt cleared, or why you went wrong, where you went wrong. So correct that. That is enough. 10th question. A jar is filled with 2 non-mixing liquids, 1 and 2. Row 1, row 2. So the one on the top is lighter, right? So heavier one goes down, lighter one is on the top. A solid ball made of material of density ρ3 is dropped in the jar. It is exactly in between. It comes to equilibrium in the position shown in the figure. Which of the following is true for ρ1, ρ2, ρ3? Tell me now. Easy question, guys. One is on the top, one is on the bottom, one is in the middle. It's 2008. So the one at the bottom is heavier. So ρ2 greater than ρ3 greater than ρ1. Clear? Easy one. Ah, nice. Good. All of you got it right. 11th one. A spherical ball. See, let us see who all got it. Karthik, Priya, Ashwin, Jaswin, Kapil, Harshvardhan. Oh, many of you got it right. Nice one. Yeah. 11th one. A spherical solid ball of volume V is made of a material of density ρ1. Spherical ball, right? Density ρ1. It is falling through a liquid of density ρ2. There is a liquid, so the density of the liquid is ρ2. Assume that liquid applies a viscous drag on the ball that is proportional to the square. So this is not the actual formula. He has changed the formula. A viscous drag, F viscous, is equal to minus kV square. It is not minus sign because it is opposite to velocity. When I'm directing the direction, no need to show the minus sign. So minus kV square is opposite to the terminal speed of the ball. So using the concept, so again, this is viscous drag, force of buoyancy, weight mg, right? So weight mg is equal to force of buoyancy plus viscous drag, right? So V, density of, what is the density of the ball? Density of ball is ρ1. If the ball is not heavy, it will go up. So density of ball should be greater than density of liquid into G. Force of buoyancy, volume into density of liquid, which is ρ2 into G, plus viscous drag, kV square, is asking the velocity. So velocity is under root Vg into ρ1 minus ρ2 by K. So whatever concept you learned, you are able to apply this easily now, right? Right, guys? Let us see how many of you got it right. Take screenshot. As soon as it is done, you should take screenshot for you to revise again. Right. It's really nice, man. People are responding. It's good. 12th one. A capillary tube A is dipped in water. Another identical B is dipped in soap water. Which of the following shows the relative nature of the liquid columns in the two? So what happens when you add soap to water? You might have learned in chemistry in everyday life. There's one of the application or somewhere in chemistry, I guess. So when you add soap water, the surface tension decreases. That is why we add this to water so that water can take out the dirt. So surface tension decreases. It is not becoming opposite or it is not repelling glass. It is decreasing. So what happens? The height will be smaller than the height of the liquid. Height will be smaller. When it is this shape, if you see mercury, in mercury, it will go down. When it is opposite shape, it should go down. It cannot be somewhere here. So these two are anywhere wrong. Now here it is increasing, here it is decreasing. But when you add soap, the surface tension decreases, so height will decrease. So option D. 12th one, option D. I hope you understood this, guys. So let me check the schedule once. Thermal properties of matter. Okay, thermal properties of matter. Let us see. The next one is oscillations. We'll get back to this. And then we have waves, oscillations, waves. Heat and thermodynamics. This is in the next session. Yeah, so transfer of heat. This is what we got now. So even expansions should be there. I don't know where it is given. Let us check later. Let us do this now. Any doubts? Again, we are not covering everything. Obviously, as much as we can, we are doing that. It is your job to go revise, recap. Yeah, so yesterday I was talking to one student and I was suggesting this plan for you. So as you already got your schedule in hand, I'm just telling you how to study. We'll get back to this. The study plan. Okay. So the study plan is what I would suggest. You got the schedule, right? So for the next day, suppose today I'm doing physics, right? So what you will do tomorrow? Tomorrow morning, complete this physics, whatever I have taught. So these concepts, complete the physics in whatever is done today, complete that by tomorrow afternoon, right? In the morning session, complete it. That is problems or whatever you haven't understood. You want to do more previous questions, more questions. Don't try to do all. I'm telling you, we don't have much time. Try to bite whatever you can eat. That's it. Don't try to do everything. So we got time, less time. So in that time, do more questions or try to understand whatever is done. In the afternoon session, before the class, afternoon, in the afternoon, revise or prepare for tomorrow's class. If tomorrow is chemistry or maths or physics, whatever, go to the schedule, check that. So based on that, there is a syllabus given there. Go revise the topics because the input or what I got yesterday from one of the students is you forgot few topics in the first year because you have been studying second year recently. Obviously, it happens with every one of us. There's nothing wrong in it. Don't need to feel bad and all. It's the same. See, generally we worry that others are doing good. They also worry the same. They feel that you are doing good. Nothing like that is happening out there. So recap the concepts before the class so that you'll understand the class better. So the equations, the formulas, or the procedure or steps, whatever you're doing, you'll understand it easily. Then again, the next day you're clearing it off. So all three chapters you're giving nearly one day because today afternoon you're giving, then preparing for the session, then tomorrow you're completing the session. So one day, three chapters. Again, another 24 hours, three chapters. Like that we are completing. We have to do like this. So you're getting around, if you're working around, 15 hours per day, 5 hours per one chapter, that is more than sufficient for you to crack the, mains and wit or whatever. 5 hours you are giving for one chapter. And after this 30 days also, you will still got plenty of time. If you plan it accordingly and work hard, you can really do well. If you're just worrying, I didn't do that, I don't do this, others are preparing well, you just lose or waste more time. So whatever happened. Use whatever is left out with you more efficiently. That is what matters a lot than whatever has happened. Okay. Don't think too much about the past. Now just whatever you got in hand, the remaining time, work on it. We are there to support you. We are trying to be as much as interactive in the session, trying to answer your questions and all. So please come forward and work on it. I'm telling you, you can really make some difference in the given time. The program has been, we even gave maths, physics, chemistry because we'll have a change of topic instead of completely doing physics, chemistry, maths, 10 days, 10 days, 10 days. Okay. So please give this time 5 hours per one chapter. So 15 hours per day, including the class session, right? Please go with the plan. We can do wonders. Right. So next one, which of the following is more close to black body? Okay. So you know this, which of it? Blackboard, green leaves, black holes, red roses. So basically, black body should be black. They should absorb as well as radiate, right? So when you are giving heat, it will absorb. When you heat it and keep it aside, it will radiate. But black holes, they absorb everything. They won't give anything back. Red roses are red. Green roses, they are not black. So blackboard paint. And there is one video somewhere I saw, Facebook, somewhere YouTube. So someone does these experiments. He was showing near to black body material. Even using torchlight, it was absorbed. It's like black hole material. It's absorbing everything. It wasn't giving anything out. It's absorbing everything. Next one, this is radiation. See, in transmission of heat, we have three things: conduction, that is like contact; convection, that is like because of the change in temperature, water or fluids they flow. Like when you boil water, the water at the bottom comes up, right? Hot water rises at the equator, which creates trade wind and all. That is convection. And the last one is radiation. So these three are in transfer of heat. So this is radiation concept. Second one, two spheres of same material have radii 1 meter, 4 meter, temperature 4000 and 2000. The ratio of energy radiated per second by the first to that of the second. So energy formula, what is the energy radiated is equal to how much is the energy radiated? So energy radiated, I'm sorry. So energy radiated is sigma AE T power 4. You know this? Sigma AE T power 4. Head of this, sigma is the constant, T is the temperature, E is emissivity, and A is the area. So this energy radiated per second, right? So Q dot, we can also say Q dot energy radiated per second. Per it's not per area, it is total area. So he is asking the ratio. So Q dot Q1 dot by Q2 dot is equal to sigma A1 E T1 power 4 sigma A2 E 2 power 4. It is of same material, E is same. Sigma is constant, same. Areas are different because radii are different. Temperatures are in Kelvin. Observe it. Temperature should be in Kelvin. If they gave in degrees, convert it to Kelvin. So area is 4 pi r square. 4 pi into the first one. First one it is 1. So 1 square into T1 is 4000. 4000 square per 4. Sorry. Why? 4 pi into area of this is 4. No. R square is 4 square into 2000 per 4. So this is 4 pi gets cancelled. 16 into 16. The thousands gets cancelled. 16 into 4 square is 16. No. 2 per 4. Again 16. How much is it? 1. Q1 by Q2 is 1 is to 1. See the radius 1 and 4. Here 4000 and 2000. So because of that, it got cancelled. Second one, is it clear? Right, guys? It is A. Vishwa, Jasmine, Nishan, Saurav. Clear, sir. Thank you. It means a lot for me. See how beautiful the technology is. We are like, thousands, maybe 1000 or 500 odd kilometer far. Still, I'm able to clear the concept, whatever you got. So long time back, if you go to, this Mahabharata and all, we have this story where like they have this kind of this video calling. They say like Krishna or someone gives something to his brother's daughter. I don't know, that's some story. So they open it and she sees like Abhimanyu, someone there. So at that time it is might be like funny what is happening there, and now it is nothing but your tab or phone, right? So technology really helping us out. Third one, the Earth radiates in an infrared region of the spectrum. The wavelength of the maximum intensity of the spectrum is correctly given by. So if you remember the formula, Wein's displacement law, lambda t is constant. Lambda into t is constant. So lambda is the wavelength, t is the temperature of the body. It is Wein's displacement law. Just direct question. According to Newton's law of cooling, the rate of cooling of a body is proportional to delta T per N, where delta theta is the difference of temperature of the body and the surroundings. N is equal to. So Newton's law of cooling, we have this four which comes out. Normally, that Q dot is how much? Sigma A T per 4, right? In Newton's law of cooling, we get it as 4 sigma A T naught cube into delta T. That is T surrounding minus T naught, or T naught minus T surroundings. Because the delta theta is small, what actually happens, there is a body. Temperature of the body is TO, temperature of the surrounding is TS. So how much is going out? Sigma A T naught per 4 is going out. How much is coming in? Because of the surrounding, the absorption is sigma A TS per 4. This is the net heat exchange. To take it common, sigma AE into T naught per 4 minus TS per 4. When the difference is small, we use binomial expansion, we use the approximation, we get this. That power 4 comes out. That power 4 comes out. and delta theta is here. So this is delta theta. So what is the power of it? Delta theta 1. It is 1. In Newton's law of cooling, it is 1. If the temperature of sun were to increase from T to 2T, radii from R to 2R, then the ratio of radiant received energy on Earth to what is was previously will be. So understand this, sun is here, Earth is here. Now this is capital R, radius of the Earth is smaller. Am I right? Now this is the concept. Later on I'll see what is the question and answer. Temperature of the sun is Ts. What is the energy given out by sun? Sigma AE Ts power 4. So I want the energy density, right? This is Q dot. But I want how much is received by Earth. So it is energy density, that is dQ dot by dA into area of Earth. Am I right? This is the energy received by the Earth. So that is sigma E into Ts power 4. Right? If I sorry, this area is radius of the sun. This area is 4 pi r square, which is radius of the sun, or rs. This is re. This is radius of the orbit. So sigma area is 4 pi radius of sun square by area. Area of this dotted line, so which is 4 pi r naught square. This is the energy density into what is the projected area of the Earth. You should not write 4 pi r square. The projected area of the Earth is pi r square only, pi into radius of Earth square. This is the energy received by the sun. Now let us see how many of you understood this. Say yes or no. I'll repeat based on your understanding. It is little logical. It is good to understand this. Okay. So somebody understood. One is asking me to repeat. I will repeat. No issue. No issue. So we'll do it again. I'm here for you. Yeah. So here, so you all know sun. Okay. So I am assuming sun is here, right? So radius of sun is Rs. Now, Earth is somewhere here. The radius of orbit is R0 and Earth radius is Rs. Earth is going in this circle about the sun. Okay. So whatever radiation energy sun is giving, it is going in all direction. How much is sun giving? Sun is given sigma AE, a temperature of sun, power 4. So sigma, what is the area of the sun? 4 pi radius of sun square into emissivity of sun. If it is perfect black body, you take it as 1 Ts power 4. This is the energy given out per second. Q dot is nothing but dQ by dt. That is energy per second. So this energy is not just going to Earth. This is falling on this complete area, which is 4 pi r0 square. R0 is the radius of the orbit. So what is Q dot per unit area? So this area is A0, area of the orbit. So area is sigma 4 pi rs square into E into T power 4, temperature of sun power 4, by 4 pi r0 square. R0 is the radius, that is this area. So this area, this complete orbit's area. Earth is not taking this whole area, it is small, taking very small area. If it takes the complete energy of sun, will burn. Right? 4 pi gets cancelled. So this is the energy per unit area. So how much does Earth get? So Earth, if you see from the sun, you just see a circle. You cannot say it is a hemisphere or something. It is projected area. Projected area. That means if you have a screen here, so we'll get a ring here, no, circle here. The shadow of the circle is pi r square, pi into radius of Earth square. Am I right or not? So that is the projected area. When sunlight hits like this, so we get a shadow like this. Am I right? Pi into radius of Earth square. So energy received by sun per second, pi Earth per second is sigma radius of sun square E into temperature of sun power 4 by radius of orbit square into pi into radius of Earth square. This is the energy received by the Earth per second. Now I hope you understood this. Take the picture. See, I didn't explain something new. I just repeated what I have done. So if you revise the same thing twice, thrice, you'll understand it. That is the logic here. Take the screenshot. I hope you understood. Understood. Okay, sir. Clear. Thank you. Thank you. So now the question is, temperature of sun were to increase from T to 2T radius R to R, the ratio of radiant energy received on there to, okay. So it just depends on rest all remains same. So what is that Q dot? First case, sigma area is same. No, area is 4 pi R square into, this is E, T power 4. In the second case, Q dash is sigma into E into 4 pi into R becomes 2R. So it is 4R square. T becomes 2T, 16T power 4. So it is 64 times Q naught. Am I right? It is 64 times Q naught. Sixth question. I hope you understood this, guys. Fifth one. A radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred to the surface is 2E by C. The momentum, if it is absorbing I by C, it is reflecting 2E by C. So how to solve this? So if this intensity is E, momentum is equal to E by C. We generally say I by C, intensity by this. C is the speed of light, I is the intensity of light. So we have a reflecting surface. While it is hitting, it is I by C. When it is hitting, going back, perfectly reflecting, no, perfectly reflecting. So it is like 2I by C. It is just like a ball hitting a wall. The momentum transferred is 2P, not P. If you are catching the ball, it is just P. If you are throwing the ball back, it is 2P. Same way it is 2I by C. Instead of I, they gave E, so 2E by C. The temperature of two outer surface of a composite slab consists of two materials having coefficient of thermal conductivity K and 2K and thickness X and 4X respectively are T2 and T1. The rate of heat transfer to the slab in a steady state is some F into A into T2 minus T1X. This will what F equal to. So you have to find out that. So where do we get this? When you do a flask, you design, you become an energy engineer, you try to decide the insulation of a body, maybe for a microwave oven or phone or a building or anything or a car. So if you see in the doors of car, they fill with the material which is non-conducting to retain the whatever heat energy inside, or to stop the heat flow from outside to inside or inside to outside. So that is where they use two different materials or different thicknesses. He gave one is K and X, 2K and 4X. Let us take that down first. So one is K, whose thickness is X, 2K and thickness is 4X, T1 and T2. If T1 is greater than T2, heat energy will flow this way. These are just like two resistors. So we take it as two resistors. Resistance is how much? Rho L by K. Sorry, rho L by A. So rho 1 L1 by A1, rho 2 L2 by A2. Instead of resistivity, we have conductivity. So R1 is L1, which is X. Rho 1 is 1 by K. Rho is nothing but 1 by K. So instead of K, rho L, right, 1 by K. This is K into area is A. And what is R2? R2 is 4X by 2K. 4X by 2K. So which is 2X by K. So what is the total resistance? They are in series R1 plus R2. So R equivalent is X by Ka plus 2X by Ka, which is 3X by K. Right? So we have E is equal to IR. So here delta T is Q dot into resistance. Delta T is T1 minus T2. Q dot is the heat flow. Resistance is 3X by K. Am I right? From this, I'm writing it here. Q dot is Kx by, sorry, Ka by 3X into T1 minus T2. So 1 by 3. So answer is 1 by 3. It is just like our current electricity heat transfer using different materials. It is current electricity concept. Resistance for current electricity rho L by A. Instead of rho L by A, I'm writing L by Ka. So L1 by K1 by A1. It is L2 by K2 A2. This is the slight difference. That's it. So resistance gets added up and you solve. This is seventh one. Is it clear, everyone? Yeah, clear. One by three. See, we are doing it together. You are able to understand. Few of you are getting the answers. These are previous IT mains question. Yeah, little old, but that is fine. And the remaining recent questions. Yeah, another thing what you can do now, order, or if you got a nearby department or bookstore and all, find this Arihant 42 years or 44 years previous IIT mains. Any author, it is fine. Disha or Arihant or XYZ, because questions are not there as their previous IIT mains questions. And recent years, we got multiple mains exam in a given year. So, excuse me, we are getting more number of questions. Get that book for maths, physics, chemistry separately. Every day do these chapters, whichever we are discussing. No, do questions in these three chapters. Do the easier ones first. How much any, like if you are able to do 10, do 10, 5, 5, 20, 20. So just reach your potential. So 5 hours per one chapter. In this 5 hours, as many questions as you can do and understand. It is not just blindly seeing the solution and verifying it. No, you should understand what he has done, why he has done. So if you do like that, you can use the time efficiently. The given time you can use really in an efficient way. So it's only 7:50. We got two more. Let's do ninth one. Shall we do that? Assume the sun to be a spherical body of radius r at temperature T. Evaluate the total power incident on Earth at the distance r from the sun. I guess we have just solved it without asking this. We already solved it, I guess. Right? Pi r naught square r square sigma T power 4 by r square. Option C. If you remember here only, pi r e square sigma e T power 4 into r square by r naught square. So the r's are different here. Right? Good, no? So eighth question is a little different question if you see. So this one figure shows a system of two concentric sphere of radius R1, R2 and kept at a temperature T1, T2 respectively. The radial rate of flow of heat in a substance between the two concentric spheres is proportional to. So one is radiating outside, the other is radiating inside. One is radiating outside, the other is radiating inside. So it's not radiation, I guess there is a material here. So let us assume this is K. Right? So what we have to do for this? I hope this is fine, guys. Last one, question. This one, there's a sphere, radius R1, there's other sphere, radius R2, right? Temperature T1, temperature T2. So at every instant, the whatever heat energy is coming out, it remains same. So at a distance R, we take a dr thickness. So for the small one, for that small resistance, dq, that heat flow, right, per unit time, that's dq, q dot we say, right, is Ka dt by dr. So what is dt? The temperature change among the small thickness is dt, and the thickness of the small one, so it's like thin shell, no? The temperature difference of thin shell is dt, the thickness is dr. So Ka dt by dr. This is the heat energy. Is that clear? So area is how much? K into 4 pi r square. Dt by dr is dq by dt. Now they are asking us, this heat flow is same everywhere. Q dot is same. Q dot is same. So K into dt is equal to Q dot into dr by 4 pi r square. Now Q dot is same, so I'm integrating this. Temperature changes from T1 to T2, radius R1 to R2. So K into delta T is equal to Q dot and 4 pi comes out of the integral. dr by r is minus 1 by r, R1 to R2. So Q dot by 4 pi into 1 by R1 minus 1 by R2, or 1 by R2 minus 1 by R1. This becomes R1 minus R2 by R1 R2 into Q dot by 4 pi. So when you want Q dot, so Q dot from this is K delta T into 4 pi into R1 R2 by R1 minus, if R2 is more, it is R2 minus R1. R2 is more, it is R2 minus R1. So this is the heat. So Q dot is proportional to R1 R2 by R2 minus R1. Take screenshot, guys. It is spherical. Similarly, in resistance also, current electricity also, we have the same thing. Take it down. Karthik, right? You understood, man. Arpit Mishra. You understood, Arpit? Nice. So just be BNS Kumar, sir, what are the easy ways to understand the physics topics or concept? Just to be clear, let us be practical. We got less time, as I said. Now we cannot study concept and then go to problems. We don't have time. Now you are already in the problem stage. So what I would suggest, as I'm saying, try to get the previous collection, not papers. Collection of questions, they segregate as topic wise. Kinematics of separately, NLM separately, they'll segregate it. So similar expression we get in capacitors, right, Nishan sir? So get that book, try to solve the questions. When you are not able to solve it, go to the concept, revise the concept, come back to the question, give it a try. You are not getting the answer, go to the solutions, try to analyze the solution, understand it. Now you should solve it. Yeah, till 2020 is fine, no issues. Even 2019 is also fine, right? So book till 2020 only we need. 21 we don't have the question. 21 also we had minds, right? That is okay. Just those 3-4 papers you can download from internet and do. But solving the question matters. So everyday plan it. We already made this schedule to guide you in one direction. Okay. So that you can prepare well. That doesn't mean just in this 1 hour you can crack IT and we are assuring your rank and all. If you have to work it. See, in gym, if you go, the trainer will tell you how to do the workouts and all. Right? You are the one who has to do it. Even practice it after the gym session, maybe more workout, then you'll get your 6-pack ab or whatever body in less time. You already missed that, so now you have to work more. Previous IIT questions, we have different publishers. What I have seen is Arihant. If you have other series, anything is good. Previous IIT mains questions, no advanced, only mains collection. For us, mains, I'm telling you, not just IIT, WIT, SRM, BITS Pilani, or BITS, whatever, we have Goa, Hyderabad, too. Amrita, all entrances will become little easy for you if you do this mains question. Please do follow. We got less time. Together we can definitely crack it. Just need to work hard. So, anonymous, when will be the AEEE exam? So, there is something called Google. Just Google when is the IIT mains 2022. So, they might change the date based on that COVID and situation. So, cannot assure anything based on it, right? So, it might change. You got 5 months nearly, or 4 to 5 months. One is near means 2 months. But if you have 2 attempts, you still got time. Any questions? How is the session, guys? So far, are you able to understand things? It is helping you out. Thank you, Siddharth. Happy to hear that, Shiva, Gomati, Aditya. So keep encouraging us and we will be encouraging you. And it becomes wonderful and awesome when you also work on it. Okay, it's not just me. You should also work on it and get back to me. So tomorrow's work for you will be studying problems on these questions, these topics. Take any book. It doesn't matter. Any book, any assignment. Do questions in this area. Recap the concepts. You can, people stuck in the concept, revision of concepts only. They keep on, revising. No, do questions. We want to know how to apply the concept, not revising the, concept regularly. How to apply the concept. Yeah, you will face problem, Shivmangal Yadav. You will face problem. That is when you have to go to the solution, check it and come back, because first time you are doing it. If you are going to gym for the first time, you have body pains, right? You get body pains. You have to get used to it. So it is a stage where you are getting these body pains. You are not able to understand the questions because you are doing it first time. So do check with the solutions, get back to this. Second time, third time, you should be able to solve on your own. So revise it multiple times. Okay, that's it from my side, guys. Anything else I can help you out, let me know. What's your on the 4 dimensions time travel feasible? No, man, I thought of this at early stages. I don't know, didn't find the answer yet. We cannot say no to anything because we never know. People, whatever they thought in the past is not possible. We are seeing them being possible now. People are cracking things up. So we never know. Might be feasible. Can you make car not? You mean you can make means you want to make an engine? Yeah, you can definitely make. Why not? Yeah, you can definitely leave the class. Good night, guys. Sorry, if you still, I guess you have to prepare more. Please do it, right? No expectations, man. I'm trying to be expecting very much less in my life. Similarly, JEE means we cannot expect anything. Tentative dates they might have released. Just check with that. Yeah, first do this mains. The next level of mains is advanced. If you are scoring enough in mains, also parallelly solve. Advanced also we get the same collection of questions. Just do it. That's more than enough. Right? Thank you. Thank you all for following. Good night. All the best.